Okay, chapter 1, section 2. Okay, chapter 1, section 2A, guys. The first few examples are very slow. And you guys are like, oh my God, I know how to do this. Great. We're solving equations. So the beauty of solving equations is that you're going to come out with x equals. Once you get x equals, you can plug it back in and make sure your answer is correct. The first step to some of these is the hardest. And then once you get past that step, then it's like, oh, okay, I can do this. It's real easy. But quick review of solving equations. You want to isolate the variable. I personally like the variable on the left-hand side, so every single time I'm going to move it to the left. If you guys like it to always be positive, then you're going to move it to wherever you want, whatever. I personally just like the variable on the left, so that's what I'm going to do. There will be some special cases. There's 2 special cases that we're going to talk about today. One where your answer would be all real numbers, meaning anything you plug in for x will make the equation true. Or you'll get something where the answer is no solution. So I'll show you those special cases at the end. In WebAssign, I believe if the answer is all real numbers, you have to type the word reals in. Last period, they had a few minutes to start their homework, and everybody kept coming up to me, I don't know how to type it in. If you read the directions for each question, it'll tell you. For the no solution one, I believe you have to type in DNE, and it says that, and it says does not exist. So please read the directions. But in a case where it's all real numbers, when you solve, the left-hand side of the equal sign will be identical to the right. It's not that you get x equals a number. You'll get an expression on the left that's the same as the right. Or if you fully solve it, you'll get 0 equals 0. That's where it would be all real solution, all real numbers. If you get an untrue statement, your variable will cancel out and you'll get something like x equals 9. Is that ever true? No. Is there ever a case where you have nothing and it's the same as having 9 things? No. So that would be your no solution case. We'll do those towards the end. All right. We're going to start off real basic here. I'm going to go kind of left to right. I'm going to go 1 to 4, 2 to 5, 3 to 6, just because they kind of mirror each other. But in a case where we're solving an equation, guys, you want to isolate the variable. So do you guys agree we would add 6 to both sides here? Okay. 3x equals 6. Divide by 3, and x equals what? Perfect. What can I do with my answer? Plug it back in and check, right? Okay. All right, so go over to 4. Isolate the variable, so I'm going to subtract 2 from both sides. I get 7x equals 21, so what's x equal? 3. Perfect. All right, do you guys think the whole lesson is going to be just like this? It doesn't get much harder. This one doesn't get much harder. All right, if you look at the next 2 examples, you notice that there's variables on both sides. So I'm going to, whenever you have variables on both sides, I'm going to say make sure each side of the equation is fully simplified, then move variables to the left, numbers to the right, or variables to one side, numbers to the other, whatever you guys like better. I like everything on the left, so I'm going to say negative 3x on both sides, and I'm going to subtract 4. If you don't like to do both things in one step, that's fine. You can do it in 2 steps, but I just like to, conserve a little time. So 5x minus 3x is 2x. My 4's cancel. Here, my negative 3x and positive 3x cancel. I have negative 12. So I divide both sides by 2, and I get x equals what? Negative 6. Perfect. What? Negative 8 and negative 4.
Oh, okay.
All right, go over to 5. Again, I'm going to do the same thing. I'm going to move my 2x to this side, so I'm going to add it. Then I'm going to subtract 3. So 5x and 2x is 7x. 6 minus 3 is 3, and my 2x's cancel. Divide both sides by 7, and I get x equals 3 over 7. Are you allowed to have fractional answers? Yes. Are you guys allowed to have x equals 0? Yes. Some people were on, let me sidebar for a second. Say they got like 14x equals 0, and they're like, it's no solution. Can I solve that a little more? How do I get x by itself? Divide by 14, right? So when you divide, you get x equals 0. That is a perfectly fine answer. X equals 0 may be an answer to something on WebAssign, on your tests or quizzes. That's not no solution. So make sure you guys understand that. All right, let's look down here at 3 and 6. Again, on number 3, I'm going to subtract 7 because it's positive. So this becomes negative x equals what? 12. Can I leave my answer like that? No, we're going to divide both sides by -1, so x equals what? -12. Good. Over here again, my 7 is positive. There's no sign in front of it, so that means it's positive. So we're going to subtract 7 from both sides. -2x equals what? 8. Divide both sides by -2, and x equals what? -4. Guys, you answer this question as x equals 4. It's not just a, oops, I forgot the negative. That's a completely wrong answer, so make sure we're very diligent and we're paying attention. Some of you, yesterday on your test, you told me 4 times 2, 6. What's 4 times 2? 8. Some of you told me 3 cubed, 9. What's 3 cubed? 27, right? Little stuff like that. You guys you have to pay more attention to little details. It's important. All right, let's go through these relatively quickly, and then we'll get to some of that are a little harder. Again, variables on both sides. So get variables to one side and constants to the other. So 7x minus 5x is 2x equals what? 16. So x equals 8. Okay, easy enough. Now, I said at the beginning, you have to make sure before you move variables to one side and constants to the other, you need to make sure that both sides are completely simplified. So what do I do with this 6 out here? I'm distributing. Good. So I have 6x minus 6 plus 4 equals, same thing with the 3. Whoops. 3 times 7 is 21x plus what? 3. Can I simplify a little more on the left-hand side? Yes. -6 plus 4 is what? -2. So 6x minus 2 equals 21x plus 3. Variables to one side, constants to the other. I'm going to go ahead and subtract 21x, and I'm going to add 2. So I have -15x equals 5. Be careful with this answer, guys. When I divide both sides, what am I dividing by? 5 or -15? -15. So my answer is what? -1/3. Doesn't matter where you put the negative, just make sure it's there. But don't make a silly mistake and say your answer is 3. Whatever number is with the x is what you're dividing by, okay? Just be careful with that. Again, number 9, very similar question. What do I do with the 4? So I have 4x plus 8 minus 12 equals 5x minus 30. All right, before you start moving stuff, can I combine on the left-hand side? Yes, 8 minus 12 is what? -4. So 4x minus 4 equals 5x minus 30. Add 30 to both sides. Yeah? Is that what you guys want to do? Huh? Okay. You want to add 4 or subtract 4? 4 is positive. Wait. You can't add 4 because it's positive. So if you add 4 to both sides, look, if you add 4 here, I was just moving the 30 to the other side. Look, if I add 30 here, what do I do with the 4x? You subtract it. It's the same thing. It's the same thing. Because some people like to do it one way, some like to do it the other. I'm not switching anything up. If you want to do it this way, I was just showing you to keep. Some people only like x's to be positive, so that's what they want to do. But if you want to do it the same way every time, subtract 5x and add 4. That's fine. So you get -x equals what? -26. So what does x equal? Positive 26. You cannot leave a negative variable. If you come out with a negative variable, then you have to divide by -1. Everybody with me? Okay, scooting along. Why we go? Okay. Okay, pay attention here. Pay attention here. Signs are going to get some of us if we're not paying attention. So I'm going to go ahead and distribute this 3. So I get 6x minus 12 equals 7. What do I do with that negative sign? I have to distribute it. This becomes negative x and then a negative 5. Do I have anything on the left-hand side that I can simplify? On the left-hand side, do I have anything to simplify? No. What can I simplify on the right? The 7 and the, what kind of 5 is that? Negative 5, guys. That's not 12. 7 minus 5 is 2 minus x. It's a positive 7 and a negative 5. So when you combine those, it's a positive 2. Everybody see that? All right, so I'm going to add x to both sides and add 12. Can I do that? Okay, so 6x and 1x is 7x. 2 plus 12 is 14. Divide both sides by 7, and x equals 2. Again, you guys can always check these answers. If you're not 100% sure, if you want to make sure you did not make a mistake with signs or something, plug it back in. And you should, when you plug it back in, the left-hand side should equal the right-hand side. All right, again, let's distribute. So negative 8x plus 4 equals 6. What do I do with that negative sign, guys? Distribute it. You're multiplying by a negative 1. If there was a 4 there, you'd multiply by negative 4. But if there's a negative 1 there, so this becomes minus 2x, what? Plus 4. Is there anything on the left-hand side that you can combine? Nope. So negative 8x plus 4 equals anything on the right? Yep. 6 plus 4 gives me 10 minus 2x. Can you write minus 2x plus 10? Sure. So now we're going to move variables to one side, numbers to the other. I'm going to add 2x and subtract 4. So negative 8 plus 2x is 6x. My 4's will cancel. What's 10 minus 4? Yes, sorry. What's 10 minus 4? 6. And then now what do? Divide by negative 6. And I get x equals negative 1. Okay? All right, guys, those are fairly simple equations. The next few, the hardest step is the first one. And then once we get past that first step of how do I begin to solve this, then it becomes easier. I'm going to do this a couple ways. I just want you guys to see. Just watch for a second. You don't have to write this all down. What do you notice here? A fraction, right? Most of you are going to say, I'm going to distribute. So when you distribute, you're going to end up with 2 over 5x plus 1 equals x plus 2 over 3. That's fine. You can do that. Now, if you're going to solve this, you have to get a common denominator and all that, right? This is a lot of work. You guys are going to have to really look at these problems and work smarter, not harder, because you're going to run out of time if you don't know different ways to solve different equations. Do you guys agree with me that I can write this equation as 2x plus 5 over 5, right? And then this is x plus 2 over 3. Are we allowed to do that? All right. If you guys have a fraction, one fraction, it's not 1/2 x minus 7 over 3 equals something. It's one fraction on the left-hand side, one fraction on the right-hand side. When you have one fraction equal to one fraction, does anybody know what we can do mathematically?
Can you multiply by 15?
You could multiply by 15, but what'd you say? You can cross multiply. You can say, look, this is 5 times x plus 2 equals 3 times 2x plus 5. Now this becomes an equation that everybody in here could do with their eyes closed. Why does that mathematically work? Let me show you. If you have 2x plus 5 over 5 equals x plus 2 over 3. On my left-hand side, guys, what would you multiply the left-hand fraction by to get rid of the denominator of 5? Multiply by 5, right? 5 divided by 5 cancels. What you do to one side of the equation, you have to do where? To the other, okay? So what on the right-hand side, what would you multiply to get rid of the 3? 3. So if I multiply 3 here, this cancels. What you do to one side, you do where? To the other. Is that not exactly what we have right here? When you have one fraction set equal to one fraction, you can just cross multiply because mathematically you're just getting rid of the denominators. So now, what do? I distribute. I have 5x, what? Plus 10 equals, what? 6x plus 15. Perfect. Numbers to one side, variables to the other. So I have negative x equals 5. So what does x equal? Negative 5. Perfect. Divide by negative 1. And then go ahead and plug it back in. Plug it back in and see if it works. Anytime you have a fraction set equal to a fraction, just cross multiply. Yeah.
When you plug it in, are you still distributing the 1 over 5, or can you still do the cross multiplication?
You can still do it. You can do it from the blue step or the original one.
Okay.
Yeah. All right, these last 3 are ones that you will likely see on a test or a quiz. I guarantee you won't have one like number 1, right? But you'll have something like this. Immediately when you guys see 13, you're like, oh no. Right? There's 2 ways that you can approach this. We can try to do what we just did. Let's look at the left-hand side. Do you see how I have 2 different denominators? Right? So how do you add fractions? You get a common denominator. What would my common denominator, guys, be between 3 and 2? 6. Okay. So just like we were doing the last couple lessons, look at your first fraction. You have a 6 as a denominator, but you currently have a 3. What do you multiply the 3 by to make it a 6? 2. So if you multiply the bottom by 2, then what do you do to the top? Multiply it by 2. So then you have 2 times 2x plus 4 plus, look at your second fraction. You have the 2. What would you have to multiply by to make it a 6? 3. So what you do to the bottom, you do to the what? So this is 3x, right? And then we can combine like terms and all that stuff. I'm not going to solve it this way. I just want to show you. So on the right-hand side, what would your common denominator be? 12. I agree. So look at this first fraction. 1/4 x. What would I have to multiply the 4 by? 3. So if I multiply the bottom by 3, then I can do the top. So I have 3x minus, why did I write 2? 3x minus, okay, multiply the bottom by 4 and the top by 4, so minus 28. Yeah. In the numerator. So we would combine like terms on the left-hand side. Then do you guys see how you have created one fraction equal to one fraction? Right? When you have one fraction equal to one fraction, what do? Cross multiply. All right. I personally would not do that. I'm showing you how you could by getting a common denominator and all that. But how many of us just hate fractions? You just hate them. You see it, you're like, oh, I hate it. Let's look at the equation as a whole. I see all the different denominators, a 3, a 2, a 4, and a 3. What would a common denominator be between all of them? 12. So watch what we're going to do. We're going to multiply the whole equation by 12. You are going to get rid of the denominators first, then you just have a linear equation. So guys, think about this. When you distribute the 12, right? When you distribute it here, you have a 12 out in front. What's 12 divided by 3? 4. So this becomes 4 times 2x plus 4. Now I'm going to put a 12. I'm going to multiply here. What's 12 divided by 2? So this becomes plus 6x equals 12 here. 12 times 1. So 3x. And then a 12 here. What's 12 divided by 3? So minus 28. Now you have no denominator to deal with. When you have a fraction or a series of fractions, you find a common denominator between all of them, and then you just multiply through. And all you're doing is taking the number that you're multiplying by and dividing the denominator. Yeah. Because when you say 12 times 7 over 3, 3 goes into 12 4 times, and 4 times 7 is 28. You could have multiplied 12 times 7 and then divided it by 3. It's the same thing. Yeah.
If there weren't any fractions on the right-hand side of the equal sign,
Good question.
would you just multiply by the greatest common factor of 3 and 2?
Right, but you'd have to do it through the whole thing because there's a 1 underneath, right?
Yeah.
Like if you had 4 over 1, so then you would multiply whatever that number is out in front, you multiply throughout the entire equation. Because what you do to one side of an equation, you do to the other to make it equivalent. So now, everybody in here can solve this equation. No problems. What do I do with the 4? Distribute. You have 8x plus 16 plus 6x equals 3x minus 28. Anything on the left-hand side I can combine? 8x and 6x gives me 14x plus 16 equals 3x minus 28. Move the x to one side, numbers to the other. So I have 14 minus 3 gives me 11x. What's negative 28 and negative 16? Negative 44, good. Divide both sides by 11, and x equals negative 4, good. Because if you multiply, if I say 12 times 2x plus 4 over 3. Can you simplify the 12 and the 3? Becomes a what? 4? All right, so then I'm going to multiply 12 times 1x over 2. Can you simplify the 12 and the 2? Becomes a what? 6. All right, then I come over here and I'm going to say 12 times 1x over 4. When I simplify, it becomes what? 3. And then I'm going to say 12 times 7 over 3. Hold on, Alec. So 12 divided by 3 is 4. 4 times 7 is 28.
The 13, my answer is like 11x minus 6 over 12.
Okay, let me finish and then I'll look at your work, okay? Okay? All right, guys, so look at 14. How would we talk about 14? Well, we don't ever deal with fractions and decimals in the same equation. That's just crazy. So you're going to want to change everything to fractions, everything to decimals. Can I change 2/3 to a terminating decimal? No, it'd be 0.666666, repeating, right? Can I change 0.25 to a fraction? What would it be? Okay, perfect. So look, you have 2x over 3 plus 1x over 4 equals x plus 2. This is a similar question that Anthony was just asking. I see denominators that I don't like. I want to get rid of them. So do you guys agree with me? There's a 1 here and a 1 here. What would your common denominator be between 3 and 4? 12. So we're going to multiply, guys, the whole equation. Whatever you do to one side, you have to do to the other. So think about this. When I distribute the 12 to that first fraction, it's 12 times 2, which is what? 24x over 3. What does that simplify to? 8x. If you want to just say 12 divided by 3 is 4 and times by 2, you can do that. I'm just trying to mathematically show you guys. So then I have plus. This is going to become 1 times 12, so 12x over 4, which simplifies to 3x. Good. Now I'm going to multiply 12 times x over 1. What is that? 12x. Good. And then I'm going to multiply 12 times 2 is 24 over 1. So it's just plus 24. The biggest thing you have to remember is what you do to one side of the equation, you have to do to the other. So if you're going to if you're going to multiply through, it can't just be just on the left-hand side because you have an equal sign, which means you're telling me that one side is the same as the other. So if you multiply one side by 2, you have to multiply the other side by 2. Luna.
I know that. You know.
Okay. So now what do we do with 8 and 3? I'll combine it. So 11x equals 12x plus 24. Subtract 12x. Perfect. So I have negative x equals 24. So what does x equal? Perfect. Good job. Those are the type questions that you guys are going to see. And it's once you get past that first step, then it just becomes a linear equation you guys have solved literally hundreds of times. You're definitely going to see something like this. Something like this is really, really, really easy to make a mistake on. When you have parentheses and brackets and all that stuff, you should always work from the inside out. You don't go left to right. You work from the inside out because parentheses and brackets, with PEMDAS, that's the first thing you do, right? So look on the very inside, 3 minus x. Is there anything I can simplify there? No. Okay, so let's move out a little bit. I still have my 4 out here. I'm going to rewrite this. This is 2x. What do I do with that negative sign? It's good. So minus 3, then what? Plus x plus 5. And that bracket, and then I have negative 7x minus 2 on the other side.
Wouldn't that be minus 5?
No.
You only distribute the negative to the parentheses?
Mm-hmm. If it was inside the parentheses, yes, but it's not. So now, guys, do I distribute the 4, or is there anything I can clean up inside? Like terms, good. So I have 4, 2x and 1x is 3x. Negative 3 and 5 is 2, good. Remember, fully simplify each side, then you can move letters to one side, numbers to the other. So what do I do with the 4? Distribute 12x plus 8 equals negative 7x minus 2. And now what? Add 7x to both sides. Subtract 8 from both sides. So 19x equals negative 10. And then what? Divide by 19. So x equals negative 10 over 19. Some of you are like, there has to be a mistake because that's a gross answer. Some of them might be. You're not going to get every single problem to work out just beautifully. Yeah.
If you can simplify that fraction, do you have to simplify it?
Yeah, if it was like negative 10 over 18, yeah.
But if we don't in the test or like the quiz,
Yeah, probably a point or two off. Okay, last few examples, and then I'm done yapping. Right at the top here, these are the special cases. You can't just look at an equation and know that's a special case, but you'll see why these are special cases here. All right, if I look at 16, what do I do with the negative 2? Distribute it. Perfect. So negative 2x, what? Minus 8 plus 3x equals x minus 8. Fully simplify each side first. So negative 2x plus 3x is x minus 8 equals x minus 8. Does anybody notice anything? It's the same thing on both sides. Think about it. If you put a 4 in for x, on the left-hand side, you're going to have 4 minus 8. And on the right-hand side, you're going to have what? 4 minus 8. Once you see that the left-hand side is exactly the same as the right-hand side, your answer here is all real numbers. You can stop right there if you want to, if you see that. Some of you are like, oh, I'm not sure. I don't want to. Okay, so let's fully solve. Letters to one side, numbers to the other. I'm going to subtract x from both sides, and I'm going to add 8. All right, well, what's x minus x? 0. What's negative 8 plus 8? 0. So I have 0 on the left-hand side. What happens on the right-hand side? What's x minus x? 0. What's 8 minus 8? 0. If you come out with 0 equals 0, that's called infinite many solutions. That means anything you plug in for x will make the left-hand side of the equation the same as the right. Does everybody understand that? Okay, so let's look at 17. Let's distribute 9x minus 3 equals 9x plus 7. All right, let's subtract 9x from both sides and add 3 to both sides. What's 9x minus 9x? 0. What's negative 3 positive 3? 0. Equals, what's 9x minus 9x? 0. And 7 plus 3 is 10. If someone owes you $10 and they give you nothing, you say, we're even. Is that true? Is 0 ever the same as 10? No. So what's your answer here? No solution. If you just leave it as 0 equals 10, and you don't somehow tell me no solution, or this is fine, the way I wrote this, 0 does not equal 10. If you want to go like this, the null set, whatever. Don't just leave it as 0 equals 10, and then I'm supposed to just guess. And another thing, guys, please stop giving me multiple choice test questions as your answers. Several of you gave me 2 and 3 different answers. You wrote something and then put or something, or And it wasn't like you were just continually simplifying and they were all the same thing. It was like 3 completely different answers and I'm supposed to pick which one. No, I'll never pick the right answer, I promise. Luke, I'm not talking to you. You just kept fully simplifying. You're fine. Yes, Luke.
So it's always going to be no solution when something's equal to 0?
Yeah.
Okay.
When a letter equals 0, that's okay. X equals 0 is an okay answer. When a number equals, when it's an untrue statement. Yeah. Yeah. All right, let's do the last 2. Let's distribute that -6. So negative 12x minus 6 minus 3x plus 12. Yeah? Equals negative 15x plus 1. What is a negative 12x and a negative 3x? Negative 15x, and then I have negative 6 and a positive 12, so plus 6 equals negative 15x plus 1. What's the answer to this one? No solution. If you aren't 100% sure, go the extra step to solve. Let's go ahead and add 15x to both sides and subtract 6. So I have 0 equals what? Negative 5. Now that should be super apparent to you that your answer is no solution. What that means is no matter what you put in for x, it will never make the equation true. The left-hand side will never be the same as the right. Now again, I'm going to talk to you guys about working smarter, not working harder. Think about this question. The first thing you guys do, some of you will see a fraction and you're like, oh, I have to multiply the entire equation, the left and the right-hand side by 2. Right? Because you want to get rid of that fraction. Guys, look at what you'd be multiplying 1/2 into. 6x and 14. What do you notice about 6x and 14? Both are what kind of numbers? They're both divisible by 2. So don't go and try to make something bigger than it needs to be. Go ahead and say, oh, this is an easy computational thing. What's 1/2 times 6x? 3x plus, what's 1/2 times 14? 7, perfect. Equals x plus 1 plus, distribute that too, 2x plus 6. Everybody with me? Okay, so 3x plus 7 over here. I'm going to combine like terms. What's 1x plus 2x? 3x. What's 1 plus 6? What do you notice? They're exactly the same. So my answer here is all, my pen is dying, all real numbers. Again, look at WebAssign. It might tell you to just type the word reals or something like that. But if you want to go ahead and fully solve, if you subtract 3x from both sides and subtract 7, you'll see that 0 equals 0. Thanks for waiting. All right, everybody good? Okay. I'll upload this. It'll be there in 20 minutes.